The Asteroid, a cosmic smoking gun, written by Neil deGrasse Tyson. The extinction of the dinosaurs, a mystery that has captivated scientists for centuries, may have a dramatic culprit, a colossal asteroid impact. Picture this: a 6-mile-wide behemoth, hurtling through space, slams into Earth with unimaginable force. The impact, off the coast of Mexico's Yucatan Peninsula, carved out the massive Chicxulub crater and triggered catastrophic events. Earthquakes exceeding 11 on the Richter scale ripped across the globe, shaking the very foundations of the planet. Tsunamis, taller than skyscrapers, ravaged coastlines, sweeping away everything in their path. The impact released energy equivalent to billions of atomic bombs, igniting wildfires that encircled the planet, turning forests into infernos. The atmosphere choked on dust and debris, plunging Earth into a prolonged period of darkness and cold, a nuclear winter that lasted for years. This cataclysmic event, known as the Chicxulub impact, occurred roughly 66 million years ago and coincides with the extinction of the dinosaurs, marking the end of the Cretaceous period. The impact theory is supported by geological evidence, including a layer of iridium, a rare element found in asteroids, in rock layers dating back to the extinction event. This iridium layer is a telltale sign of the cosmic collision. But could other factors have played a role in this ancient apocalypse? Some scientists suggest that massive volcanic eruptions, climate changes, and other natural disasters may have also contributed to the mass extinction. Volcanoes, Earth's fiery fury. While the asteroid impact presents a compelling narrative, it's not the only suspect in the dinosaur extinction case. Volcanic eruptions, those awe-inspiring displays of Earth's raw power, were also rampant during the late Cretaceous period. Imagine massive volcanoes spewing lava flows that engulfed entire landscapes. These eruptions, concentrated in a region known as the Deccan Traps in India, released colossal amounts of greenhouse gases and toxic chemicals into the atmosphere. Sulfur dioxide, a potent climate-altering gas, would have caused acid rain and disrupted global temperatures. Carbon dioxide, another volcanic emission, would have contributed to long-term warming, potentially disrupting ecosystems and food chains. Could these volcanic eruptions have weakened the dinosaurs, leaving them vulnerable to the asteroid's impact? Climate change, a gradual shift. Beyond the immediate devastation of volcanoes and asteroids, a more insidious threat may have loomed: gradual climate change. Over millions of years, Earth's climate naturally fluctuates, driven by factors like continental drift, volcanic activity, and variations in solar radiation. During the late Cretaceous, sea levels were already changing, and temperatures were in flux. These shifts, while not as dramatic as an asteroid impact, can still stress ecosystems, causing habitat loss and food shortages. Could the dinosaurs have been struggling to adapt to a changing world, making them susceptible to a final, fatal blow? Disease, an invisible threat. Disease, an invisible but potent force, has shaped the course of life on Earth. Just as diseases can decimate human populations, they can also wreak havoc on animal populations, including dinosaurs. Imagine a highly contagious and deadly disease spreading rapidly through dinosaur populations. Lacking immunity and facing limited options for treatment, dinosaurs could have succumbed in droves. While direct evidence of dinosaur diseases is scarce, the fossil record hints at the presence of parasites and infections. Could a devastating pandemic have weakened the dinosaurs, leaving them vulnerable to other threats? Impact and aftershocks, a 1-2 punch. The asteroid impact and its immediate aftermath were undoubtedly catastrophic, but the long-term consequences may have been even more devastating. The initial collision would have caused massive destruction, but the ripple effects were far-reaching. Imagine the impact triggering a cascade of environmental disasters, each compounding the next. The force of the impact could have set off a chain reaction of natural calamities. Massive wildfires released soot and ash into the atmosphere, blocking sunlight and causing a global impact winter. These fires would have raged uncontrollably, consuming vast tracts of forest and releasing enormous amounts of particulate matter. This prolonged darkness would have disrupted plant growth, collapsing food chains and starving herbivores. Without sunlight, photosynthesis would have halted, leading to a domino effect in the ecosystem. The impact also vaporized rock, releasing sulfur dioxide into the atmosphere, which reacted with water vapor to form sulfuric acid aerosols. These aerosols had a significant impact on the climate. These aerosols reflected sunlight back into space, further cooling the planet and creating acid rain, poisoning water sources and damaging vegetation. The acid rain would have had a devastating effect on both terrestrial and aquatic ecosystems. The combination of these factors could have created a hostile environment, pushing already stressed ecosystems to the brink. The survival of many species would have been threatened, leading to mass extinctions and a dramatic reshaping of life on Earth. Fossils, clues from the past. Fossils, those preserved remnants of ancient life, offer tantalizing clues about the dinosaur extinction. The fossil record reveals a complex picture, with some species declining before the impact and others seemingly thriving until the very end. This variation suggests that the extinction event may not have been instantaneous but rather a gradual process spanning thousands or even millions of years. Some scientists argue that the asteroid impact delivered the final blow to an already declining dinosaur population. Others propose that the impact triggered a chain reaction of environmental disasters, gradually wiping out species over time. The fossil record provides a glimpse into the past, but it also raises more questions than answers. Debate in the scientific community. The extinction of the dinosaurs is not a closed case. It's an active area of scientific debate and research. Scientists continue to analyze evidence, propose new theories, and challenge existing ones. Some researchers believe the asteroid impact was the primary driver of extinction, while others emphasize the role of volcanic activity or climate change. Some argue that the extinction was sudden and catastrophic, while others see it as a more gradual process. This ongoing debate highlights the complexity of the extinction event and the challenges of reconstructing events from millions of years ago. Unraveling the mystery. Ongoing research. Scientists are constantly seeking new evidence to unravel the mysteries of the dinosaur extinction. They are drilling into the Chicxulub crater to study the impact's effects, analyzing ancient rock layers for clues about climate change, and using computer models to simulate the impact and its aftermath. Researchers are also studying modern ecosystems to understand how species respond to environmental stress and how extinction events can ripple through food webs. By combining evidence from multiple disciplines, scientists hope to gain a more complete understanding of this pivotal event in Earth's history. The complexity of extinction. The extinction of the dinosaurs is a stark reminder of the complexity of life on Earth and the interconnectedness of ecosystems. Extinction events are rarely caused by a single factor. They are often the result of multiple interacting stressors. Environmental change, disease, competition for resources, and even random events can all contribute to extinction. Understanding these complex interactions is crucial for protecting biodiversity in the face of modern environmental challenges. Dinosaurs' legacy, a reminder of Earth's power. The extinction of the dinosaurs, while a tragedy, paved the way for the rise of mammals and ultimately the evolution of humans. Their legacy serves as a reminder of the power of nature and the fragility of life. The Earth has experienced multiple mass extinction events throughout its history, each reshaping the planet and its inhabitants. By studying these past events, we can gain insights into the resilience of life and the factors that can threaten its existence. The dinosaur's story is a cautionary tale, urging us to protect the planet and its biodiversity for future generations. Conclusion. A convergence of catastrophes. The extinction of the dinosaurs remains one of Earth's most enduring mysteries. For decades, scientists have been piecing together clues to understand what truly happened. While the asteroid impact presents a compelling case, it is just one piece of the puzzle. It's unlikely that a single event, however catastrophic, could have wiped out such a diverse and successful group of animals. The dinosaurs thrived for millions of years, adapting to various environmental changes. It's more probable that the dinosaurs were already facing multiple challenges, such as volcanic eruptions, climate change, and disease, which were gradually weakening their populations. These factors would have made them more susceptible to a final, fatal blow. The evidence of disease in fossils suggests that health issues were already a significant problem. The asteroid impact may have been the proverbial straw that broke the camel's back, delivering the final blow to an already struggling population. But it was likely a convergence of catastrophes that ultimately sealed the dinosaurs' fate. The combination of these events created a perfect storm of destruction. The extinction of the dinosaurs serves as a stark reminder of the power of nature and how multiple factors can converge to create catastrophic outcomes. It also highlights the importance of understanding and mitigating the threats to our planet's biodiversity. By studying past extinctions, we can better prepare for the future and protect the delicate balance of life on Earth.